Hello, this is a demo for my final project for my wireless communication class. I made a 433 megahertz on-off keying one-way radio communication system. Here is, this is the receiver graph, and over here I have a serial port window to the transmitter, so I can tell the transmitter to transmit a certain message, like say hello world, and then I can start the receiver, receive a couple seconds of data, and then I can decode the data. Here's just a debug graph, another debug graph. And we received 23 hello world messages. The messages are pretty short. I think it's roughly 1 kilobit per second, and there's 8 bytes in bits in a byte, so you get roughly 125 bytes through per second. And if your message is short, like hello world, then that's roughly 13 bytes, and so you get something like 10 of them per second. So 23 messages sounds about right for how long I was transmitting. Let's try a longer message. Hello, this is a longer message that I'm trying to draw out to show that the system is good at not producing errors. I'm going to copy the whole message so that we can check the length. And let's start recording. That message is 116 bytes long. That's 928 bits, so that'll take about a second to transmit, and I recorded well over a second of data. So now we can come in here and receive those messages, or decode those received messages. Lots of good messages. 21 out of 21 succeeded. Okay, that's too many. Let's try to get some errors in here. So if we do 2 of these together plus, let's see, another like 20 characters. That's pretty close to the maximum. Well, here. Let's make an actual maximum length message. $253, perfect. Okay, so let's take this, copy it, paste it in there, and then we will record some data. And this time, let's actually look at some of these graphs. So this is the time domain data that actually goes into the data decoder, or the data decoder that I was using. And this is just a waterfall plot showing the spectrum components with time going into the past upwards, and the color being the intensity of that frequency component. So with this, it's easy to tell when the transmitter is transmitting or not, because there's a lot of stuff going on. And then down here we can see if the data is looking reasonable. Okay, that's probably enough. So now, oops. Oh, there's a bad message. More good messages. Another bad message. that last message looks like it was probably just cut off by me stopping the recording at that time, though. So, but we got 21 out of 23 good messages, so that's pretty good already. And one of them was probably just an actually cut off message, so it's more like 22 out of 23 messages successful. All right, thank you for taking a look at my final project. That's it for the demo.